All right.
I don't know.
Yes, exactly.
So I can't just.
Yeah, exactly. You have to put a variable.
That's hilarious.
Yeah.
Okay.
All right. So
Yes.
All right. Thank you. Appreciate it.
let's talk about dynamic size arrays. So we had in our main an array and I have an array of integers. I think I call it input, right? I'm gonna do it like this. The max size, I had it as a macro, but now I'm gonna make this as a variable. Oh, it's not gonna like that, huh? It's gonna say you need to be a constant value. Alright. So what we're gonna do, can I declare an array like this? Can I do it like this? An array of 0? Yeah, exactly, right? So we'll start at 10. I don't know if I'm going to use that variable max size, but let me keep it for now. And I had a printf say asking the user enter positive number 0 to n. And I'm just going to call this current number. So this was inside a do, right? And then we got the scanf, and we say it's a digit. And we have the address of the current number. I'm gonna do this. I'm not gonna care about this size. For now, I just care if the user enter a number greater than 0 or not. Actually, let's make it 5 so you can see it better. Why is this? What did I do?
Empty.
That. So, if the user enter a number greater than 0, I want to do something with that. I want to put it in the array. current number. And whatever I do, I want to increase the size. So I got a problem here, possible problem. If I have no room, what do I do? Like if I had exceeded 5 characters, oh, I'm sorry, 5 numbers. I'm trying to enter the 6th number.
I think it's still gonna let you. It's still gonna let you type it in.
So it's gonna let me use memory for other programs when I reach that point? Shouldn't let me, right?
It might.
We don't want memory leaks either. So what I'm gonna do here,
Is that what a memory leak is?
well, a memory leak is actually an allocated memory you can no longer access.
So it's just useless, you just can't get to it?
Yeah, so basically,
If you keep doing that over and over and over again, that's why you're...
yeah, when we talk about structures and classes, I'll show you how it really happens. So, if my current size is less than my maximum size, I'm good, right? But what happens if it's the other way around? What's the opposite of less than? No,
Less than equals.
greater or equal.
Greater.
So, if I'm exceeding this current size, I gotta resize the array. Somehow. And we're gonna revisit, I mean, from now on, I told you we're gonna be talking about pointers a lot. Arrays are pointers. So let's say I don't have the problem. I assume the user is gonna enter up to 5. So, if that's the case, the input, current size, equals that current number. Right? So, and then I increment the size. Did I ever tell you what will happen if you do this? Will that work? If I put the plus plus in front instead of the n of the current size?
Will it just keep adding a number to itself? It's like, will it just keep adding a number to itself?
Well, either one adds one to itself.
Hold on.
So, in that code, in this particular code, it doesn't make a difference. So, we call this, and this is a parenthesis, the plus plus is the increment, or the minus minus, is the decrement. They are to the right of the variable in this case. That's a postfix increment. If I had it like this, it's a prefix increment. So what's the difference? So let's say I don't want to type that much. I'm going to do it like this. Now I have 2 lines, basically, or 2 instructions. 1. The plus pluses are on the right side. Let me show you what happens. I'm gonna do a print of the array here. We had a method called print array before, right?
Yeah.
So I'm gonna modify it just a little bit. Oops, the other way. So I'm gonna say, I mean, it doesn't really matter. Something like this. So what I'm doing is, the number is greater than 0, print it out, and increment the I. And if it's not, if it's negative, then just exit the loop. So let's print the array here. And, oh, what did I do? Oh, I forgot the prototype. So if I enter 1, oops. What happened here? We didn't like this, huh? Let's see, that's equal. Nope. Alright, let's debug it.
Yeah.
So, alright, so enter 5. Oh, current size, max size. So what happens is I forgot to initialize current size. So I gotta do this. Current size equals 0. Forgot that part. So now it should work. So I printed 1, 3, and then 0, right? We'll add them in a minute. Actually, on the print array, we have one for answer, right? So we had it like this, print F, I'm gonna put a square bracket here, and I'm gonna put a plus sign here, and here, I'm gonna do my if statement, I'm gonna increment answer by whatever that array was. Look, I changed my I++ to here, and I'll show you why in a second. And then I think I had it like this. So if I bring the array, I have 1, 3, 5, 0. So I printed my array there, right? So if I enter 5 numbers, it works fine. The problem is if I exceed the size of my array. So once I establish the size of the array, can I do this? Maybe something like this. Why can't I redeclare it though? Can I resize it? Actually, technically, yes, you could resize it, have your operating system start paging stuff, but I'm not going to teach you that. That works in C, but it's really, don't do that. Just don't do that. You'll understand later. So what we're going to do is we're going to make another array. We're going to make another array, and we're going to make it bigger. So usually you want a buffer. So you want to have an array that not just adds one character. I mean, if you have 100 elements, you want to keep adding, you don't want to keep resizing the array every one that is exceeded. So you pick a number. It's called padding. If you study databases, when you talk about indexes, indexes are an array. Remember, we can search very quick in a sorted array. We have this thing called padded index. And you're going to say how much you want to pad it. Let's say for now I want to pad it 10% of my current size. So my next array, my new array, is going to be 10% higher or bigger than the current size. So what's the current size? 5. What will be 10% of 5? 0.5, right? Can I increase the array by 0.5 elements? No, right? It has to be whole elements, right? So what you do is 10% plus 1, just in case. Right? So technically, I could make another array, right? And the array it's not gonna let me do this. Current size plus 1. Because it's not a constant. But it will let me do this. Well, you need to initialize it. What if I were to just do this? Will this work? No, not letting me. Now, what do I do? Well, arrays are pointers too, right?
Yes. The first address.
So, what if I treat this thing. What is, I make this function separate. And this function is going to return an array. But arrays are also pointers, right? So it doesn't let me declare like this. It doesn't let me. But it will let me do this. Right? And I can also do something like this. I mean, the address of the first element of the array. That's perfectly fine. Point. Alright, so keep that in mind for a second. I want to introduce you, and this is where kind of like memory leak starts, is how to dynamically allocate memory. To allocate memory, you gotta tell the operating system how much memory you want. So when you declare an array, you're telling the operating system, well, I want 10 integers. Well, an integer is 32 bits. So you're telling the operating system, give me 320 bits. How big is an int? There's this function called size of. It's a built-in function in C that takes a parameter of a type and it'll tell you how many. It doesn't tell you bits, it tells you bytes. So if I do, check this out, if I do printf and I do the size of a int, says 4 because it's 4 bytes. If I say size of a long, it still says 4 bytes. Size of a double says 8. What if I do size of a character? That's 1 byte. For some reason it's allocating 32 bits for a long. It should be 64. I'm not gonna mess with it where the settings are to change it. What if I do size of a boolean? That's 1 bit, right? Still grab a whole byte. In reality, it's grabbing 64 bits anyways. Because that's a Windows 64-bit machine. So, this size of function I can use to say how many bits I want. So for instance, I'm gonna just type this new size for now. I'm not gonna have it, I'm gonna erase it, but I want you to see. Basically, my new size should be the size of an integer, right? Whatever, 32 bits. And I want that multiplied by my current size plus 10% of the current size plus 1. So that's how my new array should be. Right? So my new array should have whatever number of elements I have, 5, plus 10%, in this case will be still 5, 0, and then plus 1 element, so it'll be 6. Okay, so we got 6 elements. How big is each element? Well, they're integers, so I'm just gonna say 32 times 6. So that's how much memory I want to allocate. So this is another array. I can't declare it as an array because it's not letting me. So what do? Well, can you just give me, so it'll be 6 times 32. So it'll be 192 bits. How do I tell the computer to allocate memory? There's another function called memory allocate. And for some reason, if you take this class online, it's not covered. And then when they got to my Java class, I had to re-explain how it works. So there's this method called memory, I gotta import the library, sorry. I gotta have include standard library. I think. So let's see, malloc there it is. So malloc means it's not like the scary movie, it sounds like a demon's name. Actually, for Halloween, I'm gonna be Balak. I got my white contacts. You can watch The Conjuring too. So, this function takes that's how many bits do you want? Well, I want my new size. And look what it returns. It returns void with a star. That's weird. So, so it's saying a void cannot be used as an integer. So the RAM is just this big box, right? And you're gonna say, you're gonna use it for storage, and you're gonna say what you're gonna store. It's not like when you organize your mail, which I need to go through my mail, it's like 2 months behind. You know, maybe I have a section for my mortgage papers, and I have another section for my car payments, and so on. I have this organizer. So, basically this malloc gives you that space. But the operating system needs to know what you're going to store with that space. That's why it returns a void. So, I don't know if I told you the concept of casting. So basically changing a variable to another type.
Yeah.
So for instance, if I declare a variable character, C, and I'll say this is capital A, I can convert that C into an integer. Oh, let me.